All right, so let's take a look with number 1. First, we need to approximate the intervals where each function is increasing and decreasing, and then state the domain and range. When naming the intervals for increasing and decreasing, we always look at the x values, and it's always going to be in parentheses for increasing and decreasing. So our graph is increasing. We see from this point, so this would be, it would have the x value of about negative 1.3 or 1.2. It's not exact for some of these, so just estimate. So this would be negative 1.2. And then it stops increasing when x is equal to 0. So that would be our first interval for increasing. We also see that this graph is increasing from positive 1.2 to 2. So this would be 1.2 to 2. And then our graph is decreasing from negative 2 to negative 1.2. And then we're decreasing again from 0 to positive 1.2.
Did we have to get those exact numbers? Or
no, I mean, if you put 1.5, anything, that's close to that. Like, okay. The only ones that should be off, though, would be like the 1.2 if you approximated it to something else. But the other numbers should be the same.
What if I just left it as 1 instead of 1.2?
Oh yeah, that's fine. Totally fine.
Okay.
If we had a question like this on the quiz, it would be clear. So don't stress if that was off a little bit. I think I'm going to go through all of them and do increasing and decreasing first, and then come back and do the domain and range. Does that sound okay? Or do you want to do everything for question 1 first and then move on to question 2?
Can you do it for question 1?
All right, yeah, we'll do the domain and range now. So the domain is what our graph touches from left to right. So we start at the furthest left point of our graph, which that's negative 2. Since we have a closed circle here at negative 2, we put a bracket for our domain. And then our graph ends at positive 2. And again, we have a closed circle, so that would be positive 2 there. Now for range, we go up and down. So we start at our lowest point of our graph here, which is about 0.2, I guess you could say. If you want to say 0, that's fine, or if you wanted to say, it's not quite 1, but like if you said 1/2, but I'll just say 0.2. And it's a closed circle there also, so we have brackets for our range. So we have 0.2, negative 0.2. And then our highest point of our graph ends right here at 8, so our range ends at 8. Any questions for this one? All right, let's look at number 2. So we need to find out when we're increasing and when we're decreasing. So if we just want to start going left to right, we see that our graph is decreasing until we reach x is equal to negative 3. And since we have an arrow here, it goes forever in the left direction, so we're going to start with negative infinity, and then it stops decreasing at negative 3, so our ending is going to be negative 3. Then from -3 to about 1/2, our graph is increasing. So -3 to 1.5, we're increasing. And then we start decreasing again. Actually, this is 0.5. I wish these were whole numbers because it would make things so much easier, but this is -0.5. Okay, and then we're decreasing again from -0.5 to infinity. Any questions on increasing and decreasing?
Wait, where did you get the -0.5?
From here, this point. Because we increase, we're going up until that point, and then we start going down. So this is, if this one was -1, this would just be about -0.5. So just remember when you're looking at increasing and decreasing, it's always going to be the x value, so it's going to be numbers on the x-axis. Understand? All right, so let's look at our domain.
Miss Carver, can you zoom out for 1 second?
Yeah.
It's okay. Oh wait. Let me see. All right, thank you.
All right, so for our domain, we're looking at all of the x values of our graph. So this furthest left point here, our graph goes forever in the left direction. So our domain is going to start with -infinity, and then it keeps going in the right direction here, so it ends at +infinity. And then our range, we start at the lowest point of our graph, so we see that this arrow keeps going down forever, so it starts with -infinity, and then our graph keeps going up and never stops, so it ends at infinity.
Are we allowed to put the symbol of all real numbers?
Yeah, if you wanted to, you could just put all real numbers for these.
So if you have 2 infinities in your answer, you can put all real numbers.
Right. So you can only put all real numbers if it starts with -infinity and ends at +infinity. All right, let's take a look at number 3. We need to find when we're increasing and when we're decreasing. So our graph starts going down until this point. So our graph starts at -1 or +1, and then it stops decreasing when x is 3. So it's increasing, it's decreasing from 1 to 3. And then we're increasing from 3 to when x is 5.
Miss Carver.
Mm-hmm.
So I have a question because, like, for example, the first one, something like in one, like you said, it was negative. It was -1.2 decreasing. Like, but I put 0 because I thought it was the x.
So we're looking at these numbers when we're increasing and decreasing. So it changes right here. So it's about in between -2 and -1.
Okay. Because that's what I did wrong. Like I put 0 instead of the number.
Yeah, so you're just looking at numbers on the x-axis.
Okay. Thank you.
And that's for increasing and decreasing. Domain deals with all the x values of our graph also. So this graph goes from +1, and we have a closed circle, so we put a bracket, and then our graph ends at +5. So our domain is from 1 to 5. And then our range is the y values. So we start at the lowest point of our graph, which is -6. And then our graph ends when y is +3. So our range is -6 to +3. Any questions on this one? All right, let's look at 4. So our graph starts off increasing from when x is 2 to when x is 4. So we're increasing from 2 to 4. And then from 4 to 7, our graph is decreasing. Our domain, we start from the left. Our graph doesn't start until we reach 2, and since we have a closed circle, we put a bracket. And then our graph ends when x is 7. So our domain is 2 to 7. And then our range, we start down low. Our graph starts once we hit -6. And then our graph ends once we hit -1. Any questions on this one? All right, let's go to 5. So our graph starts off decreasing until we hit x is -4. So our first interval for decreasing is -∞ to -4. Then our graph starts to increase from -4 to, we could say 3.9, -3.9 there, because it's not quite at 3. So this is this would be 2.9 because it's not quite at 3. So -2.9. And then we finish off decreasing from -2.9 to infinity. Now our domain is going to be all real numbers. So negative.
Wait, I have a question.
Yes.
Why isn't it to -infinity?
Because it goes, that's a good question, but remember we're looking at like these x values here for increasing and decreasing. So it's going to keep going, although it goes down, it keeps going in that right direction forever. So that's why it's positive infinity.
Okay, thank you.
You're welcome. And then our range is also all real numbers. So -∞ to positive infinity. Any other questions on 5? All right, let's look at 6. So here our graph starts off increasing until we reach x is equal to negative 6. So we start with negative infinity, and then it stops at negative 6. Then it starts decreasing from negative 6 to when x is negative 3.2-ish. And then our graph ends up increasing from when x is negative 3.2 to infinity.
Isn't it negative infinity?
No. So we start off, so we're looking at x values. So we start off, the graph is going left towards negative infinity. And then it ends up going right towards positive infinity.
Oh, okay.
What'd you guys get for the domain here?
All real numbers.
Perfect, all real numbers. And then what about the range?
All real numbers.
Awesome, all real numbers. Okay, any questions from this page? All right, let's take a look at number 7. So this is just like the last one we did. We start off increasing from negative infinity to negative 6. I think this is the exact same as the last one. Negative infinity to negative 6. Then we start decreasing from negative 6 to about 3.2, negative 3.2. And then we end up increasing from negative 3.2 to infinity.
While you're decreasing, why wouldn't it have a bracket?
Always for increasing and decreasing, we put parentheses because let's take a look at like this point here for negative 6. It's not included in the decreasing, so we don't put a bracket because it's not included in the increasing and it's not included in the decreasing because you can't be both increasing and decreasing at the same time. So that's why we always put parentheses for increasing and decreasing. What would our domain for this one be?
All real numbers.
All real numbers. And what's our range?
All real numbers.
Awesome. All right, number 8. Our graph starts off increasing from negative 7 to negative 4. Then we're constant from negative 4 to negative 1, which we could put that interval for constant, but it doesn't ask us for it, so we can just skip that. And then we start decreasing from negative 1 to positive 1. And then our graph ends increasing from positive 1 to positive 2. What would our domain be here for this graph?
Negative 7 to 2.
Do we put brackets or parentheses?
Brackets.
Perfect. Negative 7 to positive 2. And we put brackets. What about our range?
0 to 7.
Do we put brackets or parentheses?
Brackets.
Brackets. 0 to 7. Any questions on this one?
Ms. Carver,
Yes.
why would it be constant from -4 to -3?
I didn't put it because the original question didn't ask us. It just asks us for what intervals it's increasing and decreasing. But if we wanted to put that interval, it's constant from -4 to -1.
Okay, thank you.
All right, 13. So here our graph starts off decreasing until we hit 0. So from -infinity to 0, we're decreasing. Then we have this little hump in our graph that goes up from about 0 to, we could say, 0.8. So we're increasing from 0 to 0.8. And then from this point on, we're decreasing. So from 0.8 to infinity, we are decreasing. What would our domain be here?
Oh, it's 0.
All real numbers.
All real numbers. And what's our range?
All real numbers.
Awesome, all real numbers. Any questions on this one? All right, last one like this, 14. What is our interval that this graph is increasing? What do we put for increasing?
One to infinity.
Awesome, 1 to infinity. And then what's our interval for decreasing?
-infinity to 1.
Perfect, -infinity to 1. What's our domain for this graph?
All real numbers.
All real
All real.
numbers. And then what's our range?
All real numbers.
Nope.
Never mind. 2 to infinity.
Perfect, 2 to infinity. Do we put brackets or parentheses?
Parentheses.
So 2 is included here, so we start off with a bracket, and then we end with infinity, so we end with a parenthesis. Okay, any questions on increasing, decreasing, domain, or range? So for our piecewise functions, we start off by plugging in our number that we are restricted by. So x is less than or equal to 2. We start by plugging in 2 into our function. So we're going to find out what our function is when x is 2. So f of 2 is -2 times 2 minus 1. -2 times 2 would be -4, minus 1 is -5. So our first point for our graph is 2, -5. So we're going to go to our graph. Since this is less than or equal to, we know it's going to be a closed circle at this point. So we go to the right 2 and down 5 and put a closed circle there. Now we need to know in what direction is this graph going, how this graph is going to look for the rest of it. So we're going to plug in another number that satisfies this inequality. So we need to plug in a number that is less than 2. So we can plug in 0. Now you can plug in any number here that's less than 2. If you wanted to plug in 1, you can plug in 1. You can plug in -1. You can plug in -2, whatever you want. I like to plug in 0 because I think it's the easiest. So we have -2 times 0 minus 1, which gives us 0 minus 1, so -1. So our next point is 0, -1. So we're going to go to our graph. We stay at 0 and go down 1. So our graph is going to go in this direction. Any questions so far?
Could you have started by writing the function as a slope-intercept?
You could, but you don't need to. That would just make a lot more work for you if you did it that way. Okay, so now looking at x is greater than 2, we're going to plug in 2 into our second function. So we have -2 plus 4, which gives us 2. So when x is 2, y is 2. And we put an open circle here since we just have a greater than sign. So we're going to go to the right 2 and up 2 and put an open circle. Now we need another point that satisfies this inequality to see where our graph is going. So we're going to plug in some number that's greater than 2. We can plug in 4. So we have -4 plus 4. This gives us 0. So when x is 4, y is 0. So we're going to go to the right 4 and stay at 0. And then our graph just goes through these 2 points here. So that's our piecewise function for number 1.
How can you tell which direction the arrows will like continue in?
So that's a good question. For like the first one here, we have the functions -2x minus 1 when x is less than 2. So x is going to keep going in this negative direction here. So that's why we start at when x is 2. So we start here, and then we plugged in some other point that's less than 2. So our second point was here, and we just go in that direction. So we go from where we start and then through our second point.
All right, that makes so much more sense. Thank you.
You're welcome. All right, let's take a look
Is
at
it open circle?
the second one. The blue line is an open circle. The pink line is a closed one. So just remember that if it's less than or equal to or greater than or equal to, it is a closed circle. If it's just greater than or less than, it's an open circle. All right, number 2. So here we have a constant -4 when x is less than or equal to -2. So we're going to go to when x is -2. That means y is -4. And we have a less than or equal to sign, so we're going to put a closed circle here. And then it's constant, so it's just -4, so it's going to be a flat line. And it's when x is less than 2, so that's why we go to the left. Next we have x minus 2 from -2 to +2. So we're going to plug in those 2 points. So we have f of -2, which would be -2 minus 2. so negative 4. So when x is negative 2, y is negative 4. So we're going to go to our graph. We see that we only have a less than sign, so we know it's going to be an open circle. So we're going to go to the left 2 and down 4. So we put an open circle there. Next, we're going to plug in positive 2. So we have 2 minus 2, which gives us 0. So when x is 2, y is 0. So we're going to go to the right 2 and stay at 0, and then we put another open circle there, and we just connect these 2 points. Now we have our third piece of the piecewise function. So we're going to start by plugging in 2. So we have f of 2, and I plug in 2 because that's our number here. So negative 2 times 2 plus 4. Negative 2 times 2 would be negative 4 plus 4. This gives us 0. So when x is 2, y is 0. And we put a closed circle here. And then we need to plug in some other number that's greater than 2. So we can plug in, I'll plug in 3. So we have negative 2 times 3 plus 4. Negative 2 times 3 is negative 6, plus 4 would be negative 2. So we have 3, negative 2. So we're going to go to the right 3 and down 2. And then our graph's just going to go through those 2 points. Any questions from number 2?
Does it have to be exactly like the way you're doing it right now? Because for the green line there, my little dot starts at the negative 4, but it goes in the same direction.
So remember that it needs to start when x is negative 2. So it has to start here. So when x is negative 2, y is negative 4. So we start at the point negative 2, negative 4.
Okay.
Wait, I have a question as well. How did you know to put 3 for the last one?
I just plugged in any number that is greater than 2.
Oh, okay. Yeah.
So you could plug in 4, 5, 6, anything. Any other questions? All right, let's look at 3. All right, so this one looks kind of tricky. We start the same way. So we plug in when x is negative 4. So we have f of negative 4. We put that into our function. So we have negative 2 raised to the negative 4th power. That negative 4 just makes our negative 2 a fraction. So this would be negative 2, 1 over negative 2 to the 4th power. And then negative 2 to the 4th power would be 16. So this is 1 over 16. So when x is negative 4, y is 1 over 16. And then this is an open circle since it's just a less than sign. So we're going to go to our graph. We plug in negative 4. And we go up 1/16, so we're going to be super close to our 0 there. So that's going to be our first point. Now we need to plug in another number that's less than negative 4, so we can plug in negative 5. So f of negative 5 would be negative 2 raised to the negative 5th power. So again, this makes it a fraction. So we have 1 over negative 2 to the 5th power. Negative 2 to the 5th power would be negative 32. So 1 over negative 32, that would be super, super close to this line here. So our line is just going to go like this. We're
Do we
just
get questions where we'd have to make fractions like that?
that is an excellent question. I think Miss Boyd may be making the quiz, or Miss Meadows, so I'll have to get back to you on that, but I'll give you guys a heads up if you'll have something like that.
Okay, thank you.
You're welcome. So just know that this line, as your numbers get smaller and smaller, so as you get to like -6, -7, you're just going to get closer and closer to 0. So we can just put that line on 0. Okay, now we go to the second part. So we're going to plug in -4. So we have the negative absolute value of -4, which is just -4. And we're going to
Wait, why did you plug in -4 and not like 1?
Because we always start by plugging in the parameters that it gives us. So here it gave us -4, so we start by plugging in -4, and then we can plug in something less than -4. So here it gives us 2 parameters to start, so we're going to start by plugging in those 2 numbers.
Oh, okay.
So our first point is -4, -4, and it's going to be a closed circle there. Next we plug in 0, because that's the right side of our graph. The absolute value of 0, the negative absolute value of 0 is just 0. So our point here is going to be 0, 0. And then we're just going to put a line connecting them. We know here that our absolute value graph, if we were to, I'll do it on the side, if we were to graph the absolute value, it looks like this. So all we're doing is including the absolute value graph from -4 to 0, so just this part of it. So if we wanted to, we could plug in more numbers for x in between to see what this graph would do, but we know from prior knowledge that our absolute value graph or negative absolute value graph looks like this. So we don't need to plug in any more numbers because we know it's just going to be a straight line connecting those 2 dots. Now moving on to the third part, we're going to start by plugging in 0. So we have f of 0 is equal to 4 minus 0, which is just 4. So when x is 0, y is 4.
And that's because it was the last parameter, right?
Right. So we always, always, always start by plugging in these numbers. And now we need to plug something that is greater than 0. So we can plug in 1. So we have 4 minus 1 squared is just 1.
Ms. Carver, for the green line, you ended it and not make it a continuous line, right? Because it includes the -4. Or
Right, I had to end it because we're only looking at x values from -4 to 0.
Yeah. Okay. Thank you.
You're welcome. Okay, our next point is going to be 1, 3. So when x is 1, we go to 3. Now we see that this graph is an x squared graph. X squared graphs look like a parabola, but we can't really tell exactly what direction this goes. So we can't connect these with a straight line because this isn't a linear graph. So here we'll need to plug in more points to see what direction this graph is going exactly. So let's plug in 2. So we have 4 minus 2 squared, which would be 4 minus 4, so that was 0. So when x is 2, y is 0. Now let's plug in 3. So we have 4 minus 3 squared, which would be 4 minus 9, so this is negative 5. So we have 3, negative 5. So we can just put our line that way. So it's kind of like the ending of a parabola here. Okay, so moving on to 4. We see we have a constant here, so we know we're going to have a flat line. So we start when x is negative 2, y is 6, negative 6. And we're going to have an open circle there. So we go to the left 2 and down 6, have an open circle, and then x is less than negative 2, so we're going to the left. Next, we need to plug in points for x plus 1 to the 4th power. We're going to start by plugging in our negative 2. So f of negative 2 is equal to x plus 1, negative 2 plus 1 to the 4th power. Negative 2 plus 1 is negative 1. Negative 1 to the 4th power is positive 1. So our point here is going to be negative 2, 1. And we're going to have a closed circle here since it's a greater than or equal to sign. So we go down 2, to the left 2, and up 1. Next, we need to plug in another point. We can plug in 0. So we have f of 0 is equal to 0 plus 1 to the 4th power, which gives us 1. So when we plug in 0, we get 1. We see that we have a graph that's x to the 4th power, so we know this isn't going to be a straight line like this, so we kind of need to plug in more points to see what exactly this graph is going to be doing. I know something's going to happen in between these 2 points, so I'm going to plug in negative 1. So we have f of negative 1, negative 1 plus 1 to the 4th power is 0. So we're going to have a point right there. And then let's plug in positive 1. So we have f of 1 is 1 plus 1 to the 4th power. This is 2 to the 4th power, which would be 16. So when x is 1, y is 16, so we're going to go up really high up here, so our graph is just going to go up like this. Alright, so these are our piecewise functions.